All right, in this lesson, we're going to look at naming and drawing ionic bonds. So we've already studied a little bit on ionic bonds and have a basic idea on naming, and then once you know how to name it and write the formula, it should be fairly easy to draw the actual bond that's occurring there. The most important thing, again, to remember is that ionic bonds are always between a metal and a nonmetal. Again, metals are on the left-hand side of the periodic table. Nonmetals are on the right-hand side of the periodic table. And what we're going to be doing is when we're drawing our bonds, we are going to be transferring electrons from our metal to our nonmetal. When we do that, you can come over to these where you have the Bohr model. The electrons are going to come over here, and we're going to end up with a positive charge, which is our cation. And we're going to get our negative charge over here, which will be our anion. That positive and negative charge is what's going to attract, and then they're going to be held together basically by the force of attraction of electricity. So there isn't anything physically holding them together other than a force of electricity. Important things when you're drawing and also on naming is recognizing valence electrons. So again, valence electrons, we follow the pattern where group 1 has 1 valence electron, group 2, and so on, until we get up to 8 valence electrons in group 18. So again, become very comfortable with this so that you're good at it. The other thing that's very important is that we need to recognize the charge. For group 1, everything has a +1 charge. Group 2 has a +2. Group 3 is +3. Group 14 will be ±4. And then we start counting back down from 4 to 0, but using negatives. And we want to make sure we do that so that we are getting the correct ratios when we're doing our drawings. So the rules when you're drawing ionic bonds. The first rule, the formula tells you how many of each atom to draw. Okay, so you need to complete the formula going through the steps, identifying the number of valence electrons, determining the oxidation number from there, and then doing your crisscross method. Number 2, you're going to draw the electron dot diagram. Basically, we're showing our valence electrons. And we're going to show our electrons transferring from our metals to our nonmetals. Step 3, we're going to be adding charges. So in this step, we're going to be looking at basically how many electrons we gained or lost. This is our oxidation number. So when you said that a particular metal had a +2 charge, you should end up with a +2 charge at the end. So let's look at a few examples with this. So let's say you wanted to combine these two elements, sodium and chlorine. You look at sodium is in group 1. Group 1, and that's because they have 1 valence electron. Chlorine's in group 17. Group 17 has 7 valence electrons. That means it's missing 1 electron. So we'll put -1, could represent that we're missing 1 electron. And that will be its charge when it gains it. Next step is to crisscross it. And we don't typically like to write, so we can just write NaCl. So here's our formula. Once we've drawn our formula, this will tell you how many atoms you need to draw. So sodium, I have 1. So I'm going to put 1 in there. And sodium, because it's in group 1, has 1 valence electron. We've got 1 dot. Chlorine is in group 17, so it has 7 valence electrons. So what we're going to do, right now these two elements are neutral. So they won't stay that way though, because this valence electron is going to be moved over here. When we do that, this becomes a +1 charge. And now this one has gained an electron, so now it's a -1 charge. And this is as simple as showing your bond. So this is saying we've moved an electron over, and these two charges are what are holding it together. An important thing to note here is that these two charges should add up to 0. If they don't add up to 0, there's something wrong. Let's look at another one. We've got potassium and sulfur. Actually, let's go back over here on this. Do is name how on the periodic table. And then we're going to take the first syllable of our anion, so chlor, and I'm going to add the "ide" ending to it. So that tells us it's in a compound. All right, then I've got potassium and sulfur. So potassium is in group 1, so it has a +1 charge. Sulfur is in group 16. So group 16 elements have a -2 charge. They're missing 2 valence electrons. We go through our crisscross. So I'm going to get K2S. And I'm not going to write the 1 there because I'm just going to have to take it off. Nothing to reduce down there. So I've got my formula there. Let's go ahead and name this. This is potassium. And sulf, first syllable, and we're going to add I to that. So potassium sulfide. When I go to draw this, my formula tells me I need 2 potassiums. So and each potassium is going to have 1 dot. And it really doesn't matter where you draw your dots. And it doesn't really matter where you put your elements. And then sulfur, being in group 16, will have 6 valence electrons. So I've got 2 openings there. So in order to complete this bond, basically sulfur's got to do an all or nothing thing. If it doesn't get everything, it's not going to form a bond. So I'm going to take this valence electron from potassium and send it there. And I'm going to take this valence electron from potassium and send it there. When I do that, potassium, because I lost an electron, now I have a +1 charge. This potassium has a +1 charge. And now sulfur, gaining 2 electrons, has a -2 charge. And if you come back up here, you can kind of check your work with this also, because we have a -2 and a +1 charge. All right, if you go to this element right here, this compound, we've got magnesium, which is a +2, and a sulfur, which is a -2. So we're going to crisscross those. So I'm going to get Mg2S2. Now, an important thing, if you can reduce it down, you should do that. So we're going to get Mgs. Let's name this one. So we've got magnesium and sulfide. It's important that we reduce it down, because if you don't reduce it down, you're going to have a very difficult time drawing your formulas. So if you look at magnesium, being in group 2, it has 2 valence electrons. Sulfur, being in group 16, has 6 valence electrons. So what I'm going to do, I'm going to take both of these electrons, and I'm just going to send it straight over to sulfur. When I do that, magnesium gets a +2 charge, which is what we expect over here, saying +2. And we're going to get a -2 charge over here, and that's what we expect again from sulfur. So, and that's our bond. We're done right there. So we don't need 2 of each one. You're going to end up basically making 2 separate sets of bonds. All right, so let's look at what you do if you get one of the transition metals. Transition metals are those ones in groups 3 through 12. So transition metals, we definitely have to know what the charge is. So we got, this is iron 2. And then oxygen, because it's in group 16, is -2. We'll do our crisscross. So I'm going to get Fe2O2. Again, I can reduce that down. So I'm going to get FeO. When I name this, I'm going to go iron. And one common mistake we'll see is that people will look right here and say, oh, this is iron 1. But it's not iron 1. It's iron 2 based off of what the original charge is. So when you name it, always use that original charge. So I'm going to put in Roman numeral 2. So iron 2 oxide. So now when I go to draw this, again, it's very similar to the last one. I'm going to draw iron. And because I have a +2 charge, I kind of have to think about what that's going to mean. How many electrons would you lose? If I had 1 electron, if I lost that, I'd get +1. If I had 2 electrons, if I lose that, I'll get +2. So we're probably dealing with 2 electrons. Oxygen, we know what it is every time. It's in group 16, so it's going to have 6 valence electrons. So I'm going to send these 2 over here. So I'm going to get a +2 and a -2. Again, that's what's going to hold it together. Let's try a variation of iron. So we've got iron 3 here. So iron 3 is a charge, and then I know oxygen's -2, again, because it's in group 16. I'm going to crisscross this. So I'm going to get Fe2O3. I can't reduce anything down. If I'm going to name this, again, go back to the original charge. What was the original charge of iron? In this case, it is 3. So iron 3 oxide. Now when I draw this one, I'm going to change colors here so it stands out just a little bit. I have to draw 2 irons. So when I get something kind of like this, I kind of stagger everything. And I'm going to put 3 oxygens in here. Now let's put in our dots. We know for oxygen, group 16 is going to have 6 dots. So I'm going to go ahead and do that. And then I know how this is going to turn out, but there's really no rule where you have to put your dots. Okay, I'm going to change colors back to blue here for iron. And iron, because it's +3, again, if I had one valence electron, if I lost that, it would be +1. If I have 2, it would become +2. And if I have 3, it will become +3. So each one of these should have 3 valence electrons. So what I'm going to do, I'm going to take these 2 right here, and I'm going to send it over there. So oxygen's now pretty happy. It's now -2. That's what it wants to be. And I got 1 extra electron here, so I'm going to send it over here. That gives this a +3. On this iron, I'm going to send 2 over here. So I got -2 here. And then this extra electron I'll send here. So now this one's got 8 valence electrons, and they all have all 8 valence electrons, and our irons have gotten down to basically 0 electrons being shown. That's what we want. So I got -2 +3. -2 because I gained 2 electrons, maybe from 2 different elements, but we gained it. And then this one right here, we've got +3, -2. If I add these up, I got +3 is 6. And I've got 2, 4, 6, so -6 adds up to be 0. So everything checks out, and we're working out there. And one key thing to remember is that when you are making ionic bonds, which are between metals and nonmetals, we are always going to get new molecules with very different properties than those original elements. So give it a little bit of a try, and thanks for watching.